Okay, now we need to look at the stoichiometry of the electrolytic process. Now, electrolysis is one of two parts of the study of electrochemistry, and you recall from the introduction notes, electrochemistry is the study and application of chemical electricity. Right there. Well, in the science of physics and electricity and magnetism, the base unit for electrical charge flow is the ampere. And symbol capital A as shown here. And the amp, in short, amp is the rate of charge flow, or the amount of charge flow passing a point per unit time. And of course, in the SI system, in the Standard International System, this would be the number of coulombs, which is a measure of charge per second. Well, if we're going to apply this idea to amp coulombs per second to electrochemistry, we're going to need to apply it to a mole of electrons, because in the study of electrochemistry, we're going to be doing things like taking chrome 3, an ion, and we need to change that to chrome solid for something of like chrome plating. So how much of a charge, or how many moles of electrons do we need to deposit 1 mole of chrome? Well, there's 3 moles electrons. So what we need to do is convert this concept of amps in coulombs per second to moles of electrons and explain it in terms of electrons. Well, it turns out from reference that the charge on 1 electron is 1 point has been determined, 602 times 10 to the minus 19th of a coulomb. So what would be the total coulombs on 1 mole of electrons? So the charge on 1 mole of electrons is certainly 6.02 times 10 to the 23rd electrons times 1.602 times 10 to the minus 19th coulombs. Like that. And it turns out to be 96,500 coulombs is the amount of charge on 1 mole of electrons. Well, in terms of coulombs, amps, seconds, so forth, an amp, of course, is a coulomb per second. So what we're going to do is say 96,500 coulombs is also, if I take coulombs, multiply both sides by seconds, I will have 96,500 amp seconds. Now that's just a unit. And however, 96,500 coulombs is the amount of charge associated with 1 mole of electrons. So it's now equivalent factor here. We can use this in dimensional analysis of electrochemical process. And it turns out that 96,500 coulombs, which is the amount of charge on 1 mole of electrons, is called 1 Faraday. Or 1 capital F, like that. So we now have kind of a sequence of relationships out of the idea, and we can say 1 Faraday is equal to 96,500 coulombs, with capital C for the coulombs, which is 96,500 amp seconds, which is equal to 1 mole of electrons. So we're going to apply a certain amperage to generate enough moles of electrons to electroplate metal onto a surface. So in calculations that deal with the stoichiometry, we're going to use this extensively to calculate time or amounts of material that is going to be involved in electroplating. Okay, for our first example, and here's a problem. How much copper can be deposited from a solution of copper sulfate using a current of 36 amps for 48 hours? Now, of course, we're going to use this dimensional analysis, and so the basic problem is how many grams, we'll use grams in this case, whatever, can you deposit using a current of 36 amps for 48 hours. Well, I'm going to start with 36 amps right there. So you'll set up, well, from your question, how much copper, right here, and then you apply it to 36 amps. You can do 48 hours, but it's a little easier if you work through the amps, because this relates directly to the Faraday's law. Okay, so we want to get rid of the amps right here, and the only unit that has amps in it is the amp seconds of Faraday's law, and that's 96,500 amp seconds. Now, from the equivalence, it's 1 mole of electrons will be delivered with 96,500 amp seconds. Well, amps will now cancel out. In this copper sulfate, it will ionize to copper 2 plus your sulfate right there. Now, we need to take into account how many moles of electrons do we need to reduce copper to copper metal. Well, we need 2 moles of electrons to get 1 mole of reduced copper. So moles now drops out, and so we've converted our copper ions to copper metal. Now we have seconds in here, and so we know right now we're getting 1 mole of copper, and we should put moles in there. Moles of copper for 2 moles of electrons. Okay, now we continue. We can work through moles. 1 mole of copper Okay, so we have 64 grams per mole of copper now. Here, so now the moles of copper drop out, so we've got the how much in terms of grams per second. Well, if we talk about 48 hours, we have 3,600 seconds per 1 hour. So now the seconds will drop out, and so we're looking for 48 hours. So 48 hours, and so that drops out, and so the only unit that's left is grams of copper. So we can reduce this to 36 times 64 times 3600 divided by 96,500, right there, 2, and then multiply everything by 48, and then we'll have grams of copper over that period of time. So that works out to exactly as 2063 grams of copper, and using the 36 amps as the measure of our indicator of sig figs, we'll round that off to 2 significant figures, and we'll have 2100 grams of copper produced. So it's nothing more than a dimensional analysis problem that revolves around Faraday's law. 1 Faraday is 96,500 amp seconds, which is simply 1 mole of electrons. So this is really the primary relationship that you'll use. Also, it's, if you wanted to, go 96,500 coulombs. Okay, this next problem is a time element. How long will it take to produce 1,000 grams of chrome from electrolysis of chrome 3 sulfate using a current of 50 amps? First thing is identify the question. This is going to be a how long. Well, let's first calculate it in seconds, since we're using the Faraday relationship, and that's going to be related to some item in here. And let's go 1,000 grams of chrome. Okay, and then we work from that. The next would be grams of chrome, and per 1 mole of chrome, that would be 52 grams. 2 grams of chrome, and then once that's gone, we can get 1 mole of chrome from 3 moles of electrons, because this will ionize chrome 2 sulfate goes to 2 chrome 3s plus 3 sulfates right there. Anyway, chrome drops out. Now need to get rid of moles of electrons, so 1 mole of electrons, 96,500 amp seconds. So now the moles of electrons. Now to get rid of amps, we just simply have to use the ratio, divide by 50 amps. And once that's out, all we have left is the seconds. So now our calculation reduced to 1,000 times 3, 96,500, and that is divided by 52 and 50. All of this will come out in seconds, and so at 346 seconds. Okay, if we convert that to hours, so it's 3,600 seconds per hour, and so this will give us 30.9 hours. And if we use the 1 sig fig bring around that to 31 hours as the time it takes to deposit 1,000 grams of chromium. Okay, next we'll be moving into the galvanic Voltac cells and working with a spontaneous process in chemical batteries. So that will take place next time.